Hi everyone, my name is Amy and I work in the forestry team at PIRSA. The principal researchers and authors for projects 3 and 4 from ESC Spatial had pressing work commitments, so unfortunately they couldn't join us today. I was really looking forward to ESC sharing their insights and knowledge on the mapping and carbon farming research that they undertook for PIRSA and GTFIH, Trees on Farms research collaboration. So in their absence, I would do my best to summarise the key results of the 2 projects. So let me start with some more information on Jeremy Wilson and Anthony Hay from ESC. They both worked on Project 3, which provides a spatial analysis of tree plantings and estimates potential carbon credits and wood volumes. Jeremy is a leading Australian forest and natural resource strategist and is recognised for his expertise in growth modelling, yield analysis, carbon forestry assessment and modelling, and strategic harvest planning. In 2010, Jeremy co-founded ESC Mapping and GIS, now known as ESC Spatial, and provides specialist advice in relation to the implementation and customisation of GIS and the analysis of forest resource data. Jeremy has 30 years of GIS modelling and planning experience within large-scale forest management companies and consultancies in Australia and New Zealand. Anthony is an experienced spatial analyst with deep forestry expertise. Prior to joining the ESC team, Anthony was an independent consultant providing spatial analysis and modelling solutions to the forest and wood products sectors in southwest Victoria and South Australia. The objective of Project 3 was to determine the plantation and carbon productivity information for privately owned agricultural areas within southeast South Australia and southwest Victoria to support plantation forest expansion. The area of interest for the project is centred around the Green Triangle National Plantation Region, but data also extends across other areas of South Australia and Victoria. The outcome is an interactive web map where existing and hopeful plantation growers can find relevant estimates of the likely amount of saleable wood and carbon credits for a given property according to a mapped grid. It should be noted, however, that these models and layers do not consider current agricultural land use, accessibility, land values, or land use planning. All of these and other factors would need to be considered as part of any standard due diligence before deciding on a forestry or carbon project for a given property. So the project boundary was shown on the previous map. So the scale of modelling was set to a resolution of 1 kilometre to provide enough information to assist with decisions around entry into plantation forestry and the carbon market. However, at this scale, results are not suitable for on-farm planning. Existing plantation estates, national parks and conservation reserves were excluded from the layers. So APSIM is the Agricultural Production Systems Simulator, a computer software model originally developed in 1991 that simulates biophysical processes that drive plant biomass in agricultural systems. Since 2020, models for forestry species were introduced and forestry inventory data, such as tree height and stem diameter, were put into the system. And these are calculated by analysing their statistical relationships with biomass. APSIM was used in this project to model the likely forest wood harvest volumes generated at thinning and final harvest for 2 Tasmanian blue gum and 2 radiata pine management regimes. This was restricted to areas with long-term average annual rainfalls greater than 600 millimetres. FullCAM is a full carbon accounting model. For forests, it uses geographic location data and forest management information to estimate carbon stock change over time. For the web map, FullCam was used to provide the total Australian carbon credit units, or ACCUs, that could be available under the Tasmanian blue gum and radiata pine regimes. Again, this was limited to areas with long-term average annual rainfall greater than 600 millimetres. FullCam was also used to generate the total ACCUs that could be available under a permanent environmental planning, which could be a mixture of tree and shrub species that are native to the area. The model was limited to areas down to 300 millimetres long-term average annual rainfall, and this modelling was included to provide carbon information for areas where commercial plantations may not be financially viable. A spatial layer on cartage or road distance to wood markets was also generated from a GIS network analysis modelling and provides distances to key ports and processing hubs currently available across the Green Triangle. Other reference layers included other specified regions for the Carbon Farming Initiative Water Rule and the Lower Limestone Coast Prescribed Wells area where commercial forests must have a water licence. So Table 1 from the Project 3 report provides a summary of the 4 plantation management regimes modelled in APSIM and FullCam. The modelled plantation regimes are the same as those detailed in the Project 1 report. The APSIM models for the 4 plantation regimes were developed with assistance from Dr. Philip Smethurst, soil, water and plant nutrition scientist at CSIRO. A calibration process was undertaken which involved comparing in-field measurements from permanent growth plots against predicted values generated by APSIM. Various assumptions were made in APSIM on climatic, soil nutrient, soil water, tree modelling and environmental variables. During the tree modelling, APSIM also modelled water use by tree roots, and average annual and maximum annual water use are provided in the web map. These results are not validated and are provided for general interest only, but validation of such values can be undertaken by comparing with satellite-derived evapotranspiration models, but this was beyond the scope of Project 3. To ensure the calculations used in this project would be relevant for carbon projects going forward, the 2023 version of the FullCam software was used over the current 2016 public version currently in force under the ACCU scheme. The results section of the report covers the calibration, adjustment and final output of the APSIM models in detail and provides examples of the mapped outputs. Table 11 in the report provides descriptions of the web map attributes. The APSIM radiata pine standard rotation and FullCam attributes are shown on the slide. For example, when we see a figure for MAI cubic metres per hectare per year on the map, it is the estimated mean annual increment or average cubic metres per hectare per year at harvest, which indicates how productive a forest is. Another example is when we see a FullCam environmental planting ACCU figure. It is the total carbon credits estimated to be issued per hectare over the 25-year crediting period under the Reforestation by Environmental or mallee planting 2014 method. Now onto the actual web map. It was developed using Esri's ArcGIS online software, and it can be accessed from the GTFIH website for free, and it's on there up at the moment. When you first go to the link, you will see this screen, which asks you to acknowledge that the modelling and outputs are indicative only, and that you should seek advice regarding the values presented. This one shows the APSIM standard rotation blue gum total harvest volume outputs. The areas modelled include the Green Triangle, Mount Lofty Ranges and Kangaroo Island. In the legend to the right, the red to orange shows the lower harvest volumes, while the yellow to green shows the higher harvest volumes. This slide shows the APSM standard rotation pine total harvest volume outputs. Again, red to orange shows the lower harvest volumes, and yellow to green shows the higher harvest volumes. It should also be noted that the APSM models appear to predict total volume reasonably well for both pine and blue gum when compared to the actual data, so the figures provided should be reasonable. This slide shows the full chem outputs for mixed permanent plantings. Notice how the layer extends to areas down to 300 millimetre average annual rainfall and includes the Yorke Peninsula and Murraylands in South Australia, as well as other areas in Victoria. This slide shows what it looks like when you zoom in on the map. This is an area near Naracoorte, and at this scale you can see the land parcels layer. If you right-click on the map, it will pick up a section of the mapped grid and display a box with further information. Since the area is outside the 600 millimetre or more rainfall zone, you will get a message stating that only information on permanent environmental plantings is available. This example is near Clay Wells. And if you right-click on the map, all the full chem outputs as well as the APSM outputs are shown in the box. So still on this Clay Wells example, if you scroll down in the box, you can see the other plantation regime data as well as travel distances to processors and ports. If you zoom in even further, then you'll be able to see land parcel numbers. So this is an example from the wood processing and export layer. So as you can see, there's quite a few wood processors in and around Mount Gambier. So this slide shows a layer on the lower Limestone Coast Water Allocation Plan water management area. So this may assist you with identifying which water management area applies to a property, since forestry is required to have a plantation water licence. So in total, there are 14 layers that you can play around with, as well as base layers that include satellite imagery. In conclusion, the interactive web map allows landholders to get a feel for how their land may perform in terms of wood production and carbon credit generation relative to other land. The map presents a range of values stored in spatial layers. However, appropriate background or experience is required to interpret them. Some of the information in the other projects presented today may assist with this, particularly projects 1 and 2. There is also potential to enhance the user interface of the web map by reporting the outputs of each layer in a more descriptive manner and linking to relevant supporting information. And we're also in the process of putting together a user guide for the web map, so that will help people have a play around with it.